Yes. I would like to talk today now about some results of my analysis with colleagues of how values and social values have been involved with climate science in various ways. It doesn't advance. The early and continuing resistance from part of the core detection and attribution community in climate science to new methods introduced from others since 2011, we find has been unproductive, and the objections have missed their targets. And especially analysis by Reskes and I, much of this debate has been involved implicit or explicit discussion of social values. And I'm going to discuss briefly the main two methods and their strengths and weaknesses. We've also found that more discussion of the societal risks of under-attribution of human effects on climate and the dangers of under-reporting of climate change are needed. In addition, third, examining the role of storyline attribution methods in legal reasoning clarifies the fundamental value of its causal approach, as I'll show using an example from US recent legal matters. And finally, I briefly review contrasts between the two methodologies. Risk-based approaches can give probabilities of risk, but not causal accounts or future projections. And storyline approaches can give informative causal individual accounts, but usually not quantitative accounts or quantitative projections, although they can give predictions using their causal analyses, unlike the risk-based account. Just to review what you've learned this morning, the earliest methods commonly used to attribute extreme events were first developed and applied in the early 2000s by Allen, Stott, Otto, and others, who developed and then applied the now conventional and most widely used probabilistic technique for attributing climate change to extreme events. It involves examining the event as one in a class of events, for example, heat waves or floods or droughts, and using climate models to compare the probability of the event under factual conditions, just to review, represented as P1 with its probability under counterfactual conditions represented as P0, in which the climate, contrary to fact, did not undergo greenhouse warming and anthropogenic changes in general. The relevant probabilities are arrived at through studying climate models as well as empirical data. And in this risk-based approach, the primary objective is to estimate probabilities and related diagnostics, such as the fraction of attributable risk and the risk ratio. My way of best understanding the various different approaches in any scientific debate is to use my logical and pragmatic tool, the logic of research questions, or I call it LRQ for short. I analyze both what the precise research questions they're asking is, as well as specifying what the possible and responsive logical answers to that specific research question look like, assuming that a given scientific community in which the research questions are investigating is. Now, I found that in many scientific disputes examined so far by a variety of researchers using my suggested logical tool, LR2, the folks involved in the debates were talking about fundamentally different things or had different goals of explanation. And that's been true in applications of LRQ in animal behavior, climate science, archaeology, genetics, neuroscience, and several other branches of inquiry, and I think it's true here. Now, take the risk-based research question asked in typical DNA of extreme events. What is the probability of a specific class of weather event given our world with global climate change relative to a world without global climate change? The risk-based approach possible and responsive answers are listed here, as the risk will increase, will decrease, or will be unaffected by climate change. To review further, Kevin Trenberth, John Fusillo, and Ted Shepard contrasted the now conventional risk-based approach with what they dubbed a storyline approach to attribution that seeks to explain the origins of singular extreme events rather than classes of events, and the influence of climate change and other causes on those events, acting as an autopsy of the extreme event. And one of the most urgent things that I've been trying to convince people of since 2015 and learning of this method is that the storyline approach uses a special logic of its research questions, distinct from the traditional methods, which makes it especially useful and applicable for some purposes. Given whatever conditions they want to keep constant, what is the effect of climate change on the impacts in that system? Now, those questions are asked in an analogous way to those in an autopsy or accident investigation, as Shepard notes in this slide, which is derived from the IPCC report. And you can see these meanings being appealed to here in the new IPCC report on the latest climate science attribution methods. In comparison, consider a simple storyline research question here. Given the conditional state of the extreme event, how did climate change alter its impacts? And possible and responsive answers are that climate change made the event more or less severe or had no effect on the impact. You can see this graphic version of our causal analyses presented here, with each node serving as a possible causal nexus and the arrows indicating possible directions of causal effects. Note that the orange impact nodes at the end, right side, serve as endpoints of the causal graphs, while the human contributions to global warming appears as nodes on the left side. But now that we've got the two attribution methods firmly and clearly on board, let's look at the logic of research questions and possible and responsive answers for various accounts of the Boulder, Colorado excess rainfall event of 2013, often called the Boulder flood, a controversial extreme event. And whenever we look at an event, I try to understand the logic of research questions of the example. What's the relevant research question to account for the Boulder flood of 2013, a controversial extreme event? What are its possible responsive appropriate answers? Taking a research question under the storyline approach, it might be, given that the Boulder, Colorado flood of 2013 happened, how did climate change affect the severity of the flood, other things being equal? And note that this research question assumes that the Boulder flood occurred when and where it did, and also assumes all the climate and weather dynamics associated with its occurrence. And here is how the Clausius-Clapeyron relation could make an increase in water availability with warmer air for the Boulder rainfall. On Trenberth et al.'s analysis, climate change led to the increased water in the air over the ocean, which was funneled into the Boulder flood from down south, thus increasing the amount of rainfall and thus the severity of the flood itself. That's a typical answer to a storyline style extreme event question. It concerns the single event and some of its causes, including climate change and thermodynamics, in the absence of adequate dynamical modeling. In this approach, they typically tend to make type 1 error false positives. And I'll talk more about that in a second. One scientist who was unconvinced by the argument to consider the scientific approaches to analyzing extreme events is Martin Herling of the U.S. National Oceanographic and Atmospheric Administration, or NOAA, a meteorologist who was responsible for the first study on the Boulder flood, a risk-based account. He and his colleagues concluded that there was no effect from global warming. If anything, they said, climate change may have made the Boulder event even less likely. So here's his analysis. Um, uh, he said the research question under this analysis: what's the probability or risk of a particular class of weather events like the Boulder flood given our world with climate change relative to a world without such change? And his answer was the risk of this type of event, like Boulder, will decrease because of climate change. That's the conclusion of his analysis in the paper. And note that this sort of study is more likely to underestimate the occurrence of events under investigation, or to make more type 2 errors, which are false negatives. The National Academy of Sciences, in their study in 2016 on DNA, said that the approach in framing, in my words, the logical research questions of an attribution study may affect its conclusions. In addition, Trenberth et al. Criticized the dynamical portion of Herling's models, saying they didn't have a high enough resolution to make judgments about the amount of precipitation in the Boulder flood or to model where it came from, key components of the Trenberth analysis. That point about resolution was taken up in a 2017 paper by Party Paul et al., who used a combination of risk-based and high-resolution storyline autopsy methods to give a causal mechanistic model for flooding in Boulder, using an approach that my co-authors and I are now calling robust event attribution, which I'll say more about in a second. They conclude that greenhouse gas drivers increase the magnitude of heavy Colorado rainfall for the week of flooding by 30% using both risk-based and storyline methods. And that 2017 paper is a lovely paper because it demonstrates what Shepard argues about the complementarity of the storyline and risk-based accounts, using both to strengthen its results. This is the complementary position that Naomi Oreskes and I have endorsed for the two methods as well. This type of study makes both type 1 and type 2 errors, which may be understood either as a catastrophe or as a way to balance things out. This is the balancing approach is the approach that's taken in our new paper by Justin Donhauser, Party Paul, and I in a paper invited by the BAMS editors that's currently under review. And we take a complementary approach to the methods that we call robust event attribution, or RIA. And working with both Naomi Oreskes and Ted Shepard on different projects, I emphasized that the different approaches to attribution analysis, the risk-based and storyline approaches, had different approaches to preferred error. And here we encounter social values. The sometimes heated arguments about which attribution methods should be preferred, either in a given case or generally, can have significant consequences for social values. Let's see how now in detail. In application of the risk-based approach, Shepard is here considering a very important problem concerning whether the dynamical portion of the climate models being used in attribution are believable and can be used as the basis for knowledge. To be sure, Shepard frames a serious problem with type 2 errors that appears using the risk-based approach, writing that if an extreme event was caused in part by extreme dynamical conditions, then any risk-based analysis using a climate model also has to address the question of whether the simulated change in the likelihood or severity of such conditions is credible, and if plausible uncertainties are placed on those changes, then the result is likely to be no effect detected. But absence of evidence is not evidence of absence. And that's a classic setup of the propensity of risk-based methods toward statistical type 2 errors, which are false negatives, a result that an effect did not happen when it actually did in real life. And this brings us to an arguably very important point, which is that overstatement of human effects, a false positive or type 1 error, which is the kind of error risked by the storyline account, is perceived by the DNA community of scientists to be worse than understatement, a false negative or type 2 error, risked by their own account. And for example, Stott et al. In 2016 wrote, by always finding a role for human-induced effects, which is what they thought the storyline did, attribution assessments that only consider thermodynamics could overstate the role of anthropogenic climate change when its role may be small in comparison with that of natural variability, and do not say anything about how the risk of such events has changed. First of all, note the concern here about making too many type 1 or false positive errors, or overstating the role of climate change. Stott also writes that carefully designed operational attribution systems should help societies understand how they're being affected by climate change and how to avoid the worst outcomes. But what specific research questions and methods would optimize such information? To avoid the worst outcomes, the risk-based approach might make precisely the errors we're afraid of, possibly missing the worst outcomes or giving us false negatives, won't it? That is, saying nothing happened when it did actually happen. That is a type 2 error. The idea that overstatement is worse than understatement is a common one in climate science, as Briss and Al showed in, showed in 2013, and is recapitulated in the discussion of use attribution studies to guide adaptation. So Stott and colleagues stress that mistakenly attributing an increased risk of an extreme event to climate change could lead to poor adaptation decisions. Time and money might be spent preparing for events that won't occur, for example. They also warn against the danger of premature attribution. And all that's true, but the argument is asymmetrical. What about the risk of understating the threat and therefore taking insufficient action or failing to hold responsible parties accountable? The risk of spending money needlessly or assigning blame prematurely is clearly articulated and warned against, but the risk of understating the threat and therefore taking insufficient action or failing to hold responsible parties accountable, which has, arguably, at least in the US, been going on for a long time, it's not addressed at all. And looky here, Miles Allen takes an importantly asymmetrical approach to error. He suggests that if the scientific community as a whole is too conservative, missing effects that are actually there, this does no particular harm to climate scientists as a group. An individual might miss out on a high-profile paper, but that would be a small price compared to a reputational harm of claiming a positive result that subsequently turns out to be false. Looking further at these claims, we can see that Allen implies here that there's no reputational harm to missing effects, especially bad events, but this is clearly incorrect, as Zareski and I point out. Rather, significant reputational harms can accrue to experts who fail to predict important events. Think Pearl Harbor or 9/11, or who fail to recognize and warn against adverse events in a timely manner. For example, the Fukushima nuclear meltdown, the L'Aquila, Italy earthquake, or the Flint, Michigan lead in the water supply cases. Um, You've got, in essence, detection and attribution scientists maintaining the conventional scientific view that in research, a type 1 error, false positive, is worse than a type 2 error, a false negative, and declining to consider the suggestion that in planning for climate change, the opposite might be the case. So, contrary to what is implied or claimed by many, it is not true that scientists always assume a standard of avoiding type 1 error. The clearest case comes from pharmaceuticals, where it must be demonstrated that a proposed new drug is both effective and safe. For effectiveness, scientists assume a null hypothesis of no effect, that the drug is not effective must be shown that it is, or at least it's more effective than a placebo or an existing treatment. So, for showing safety, scientists must prove that drug does not have adverse effect. So in this case, the null hypothesis is adverse effect, and scientists must demonstrate this is not the case. The reason for this practice is clear. Society is attempting to protect itself from two types of potential harm. First, the harm of drugs that don't work. Second, the harm of drugs that have damaging side effects. The harm is different with respect to these two concerns. And we can generalize. The choice of the preferred error, type 1 or type 2, false positive or false negative, in a case where societal harm is relevant, does depend on which harm we most wish to avoid. For example, cancer screening is another area where the default hypothesis is not necessarily negative. Screening tests are designed to be sensitive, resulting in a high rate of false positive tests or type 1 errors. We prefer these because of the relevant risks. False positives lead to, for example, unnecessary anxiety, costly, sometimes dangerous follow-up tests. But in medicine, unlike in current DNA practices in climate science, we generally prefer the false positive to the false negative or type 2 errors, lest a case of cancer be missed and the patient suffers unnecessarily or even dies. The crucial point here is that neither approach is intrinsically correct or incorrect. Neither approach is a priori scientific or unscientific. Rather, we judge one risk to be more severe than the other risk in its particular context and in light of the particular set of concerns and values. And we frame our analysis accordingly. Thus, we may prefer the false positives to the false negatives, just as proposed by the storyline approach to climate attribution. Given this, we may want to consider the suggestion about storylines is to make climate science more like medicine in its assessment of risk with regard to social values. But now in climate science, the testing is insensitive, with a low rate of false positives, a low rate of type 1 errors, little overreacting, and a high rate of type 2 errors, with risks to society of underreporting. There are far fewer cases than in medicine when it occurs, and if we're wrong in our attribution, it's really not easy to find that out by doing it like a follow-up test or a second opinion. The severity of false negative versus false positive errors depends on the consequence of each of the two. In this case, consider, for example, weather warnings and the cost of warning about severe weather when nothing happens versus the cost of failing to warn about extreme weather when it does. In addition, in the case of false positives, the money spent for adaptation may be in the billions. Equally, costs will be in the billions and in lives if we fail to attribute human influence and fail to adapt. So it may be the decision between being bankrupt from adaptation or dead from climate impacts. We conclude that there needs to be more explicit discussion of the risks and costs of both underreaction and overreaction with regard to society and its values, not to the community of climate science scholars and their reputations. The point is that promoting storyline approach does not amount to suggesting an unscientific approach, as is sometimes, and in fact, sometimes often implied. But it does move us into value considerations. But it's a serious error to buy the notion sold by some risk-based researchers that their approach is, in contrast to storyline, properly scientific and value-free. It is not, as I hope you can see by now. Avoiding false positives clearly has social costs of potential endangerment and death from unanticipated extreme events. This last issue needs to be balanced against the desire for accuracy and precision and the avoidance of false positives in analysis. But again, no one is actually value neutral in this debate. All sides incur costs of some social value kind. So it's up to society to decide which costs and benefits it values most for climate attribution and information used for attribution and preparation. It's also important to understand that the risk-based approach cannot technically give you causal accounts. Here's the balance. Either you can get precision and accuracy along with the endangerment that comes with high false negatives of the risk-based approach, or you can get the more informative storyline approach useful for prediction and understanding the causes of changing extremes. So it's really important to understand that the risk-based approach cannot technically give you causal accounts. I'm perfectly aware that they frequently make causal claims, but I do insist that this is highly inappropriate given the probability tools that they're using, which do not entitle them to such singular causal claims. That is, only the storyline approach gives you singular causal analyses out of the two approaches. Again, risk-based approach as counterfactual claims about classes of events can give us neither causal accounts of individual events nor predictions of future events, both of which the storyline approach gives. If you want to know more about this, you can read about it in these papers here, and I'd be happy to send them to you if you shoot me an email. Thus, that's why under a storyline approach to error, there is a lower risk to society overall of underreporting and underreacting and under-attribution. Now, note the consideration of the role of social context, and particularly the recognition that in different contexts, society may have a greater or lesser concern with errors of a particular type. This demonstrates that this is not a matter of right or wrong in any absolute sense. It's rather that how we view the relative risk of overestimation versus underestimation of harm is context dependent. And here is an application of my analysis of value-based standards of error evaluation with the Reskies by among the most rigorous group of climate scientists. The hurricane scientists, who have always been the most hardcore at resisting requests to attribute climate change to any given hurricane or hurricane pattern. Let me be clear. These are the folks who have always resisted attributing hurricanes to climate change. You've seen them on TV saying, no, we don't know whether climate change played a role in this hurricane. And the report says, yeah, but is this due to global warming? And they say, we can't actually say that. We're not going to say that. We haven't done a study, and there isn't a study. And so when these hurricane folks adopted our proposed evidential standards in the leading journal on weather and climate science, BAMS, they published the results using Shepard's and our recommended standards side by side with the usual attribution standards, so that their readers could see the difference and judge for themselves. So that's Thomas Knudsen and Carrie Emanuel and other leading hurricane scientists tried in this paper an important methodological experiment when they published results using both standard methods and our recommendation to reduce type 2 underreporting errors for every hurricane basin around the world. So users of their analyses will be much less likely to make the errors of underestimating the role of climate change on hurricane frequency, strength, and size because of this study. The stated purpose of this study was to provide more socially useful information useful for planning and adaptation, how to avoid damages from hurricanes, and plan for them. They wrote about our methodological recommendations that, as discussed by Lloyd and Reskies, for future planning and risk assessment, one may want to reduce type errors. For example, planners for infrastructure development in coastal regions may want to consider emerging DNA findings, even if not at the, right statistical significance level in their planning and decision making. And this is an illustration, they say, of the power and utility of an alternative account operating under different, and we say equally scientific, statistical standards. So what Shepard, Oreskes, Mike Mann, Justin Donhauser, Party Paul, and I have been arguing for is a complementary use of multiple methods when appropriate to the issue at hand and when data are available. So there's thus an opening for our articulation of robust event attribution, which combines what we see as the complementary analysis of the probabilistic singular causation or storyline approach with risk-based approach. And Justin Donhauser is my ex-postdoc on an NSF grant, and Party Paul, whose elegant work on the Boulder excess rainfall I've already discussed today, is our other co-author. It isn't just a debate about simple methods and probabilistic and storyline. In any debate about the superiority of risk-based or storyline approaches, there are always implicit questions or disagreements about what counts as good science, what counts as a satisfactory explanation, and what people or policymakers really want to know about extreme events. Which questions are most urgent to pursue? Which matter most to society? Now, Eden et al., 2016, whose co-authors include one of the original advocates of the risk-based approach, say that the type of analysis of most relevance to users is, in fact, the risk-based approach, as you see here. Attribution analyses aiming to answer questions of most relevance to stakeholders should, and they use the term holistic to refer to risk-based approach, probabilistic approach, use the probabilistic approach in order to prioritize an understanding of the changes of overall risk, which they deem the most important thing, rather than the contribution of different factors, which is how they describe and refer to the storyline analysis. But it's precisely this type of causal analysis, the latter, of the contribution of various causal factors that's most urgently needed from current climate model analysis, as far as in practice intersection of climate and the legal context goes. So in the recent case, for example, of Juliana v. US, The plaintiffs claimed constitutional violations via specific harms they'd undergone because of greenhouse gas-induced global warming, and they say it aggravated particular kinds of extreme weather and climate events. And among the legal questions involved, there's an event attribution case at the heart of the case, and we published on this last summer. Climate scientist Kevin Trenberth gave testimony using the causal conditional storyline attribution method, supporting many of the 21 plaintiffs. And the US government responded with an IA modeler, John Wayant, as to oppose Trenberth's analysis. Now, climate lawyer Berger et al. Explain why the Juliana case is so significant. They say Juliana, the case, illustrates some of the challenges that the plaintiffs, the complainants, in other words, may face in establishing a causal connection to individual injury. The plaintiffs dedicated a large portion of their briefs and expert testimony to defining the causal nexus between climate change and specific injuries. And if the case had gone to trial, this would have been one of the key factual disputes. And they go on to say why, again, further, the Trenberth testimony was so important and why storyline is so important. One crucial question for courts as they deal with the factual disputes is the question of whether, in the absence of an attribution study of matching geographic and temporal scope, can you show that the observed impact was caused by anthropogenic influence on climate change? And given that such a detailed attribution study would essentially be impossible to perform, the question then is on our analysis to ask whether it's possible to reason from the general to the specific in these cases. Were this possibility of reasoning from the general to the specific to be excluded, it would basically eliminate the use of tort law to address climate damages. And it's not clear how climate damages could be addressed at all legally. And Juliana, the case has been dismissed on unrelated legal grounds, but the question itself has yet to be tested in US court, although it's been tested elsewhere. But we want to sketch a few of the basic principles of reasoning that showed up in the case and talk about how the science of extreme event attribution can be aligned with legal scientific standards of reasoning and social values, especially with the inferences of Wayant, the opponent, about extreme event attribution. So Wayant's core argument is that the current state of scientific understanding is not sufficiently developed to serve in this lawsuit. The climate impact models can't determine the regional effects of global climate change to the degree of specificity necessary to causally link specific weather events to individual injuries. And Wayant continued, the current set of climate and climate impact models, and here he's talking about storyline models, cannot separate the various causal factors with sufficient certainty to disentangle the effect of regional climate changes from the effect of other region-specific confounding factors. And Wayant goes on, and contrary to what Wayant suggests, Trenberth did actually detail the causes of the damage suffered by the various complainants in his testimony, but then Weyant critiqued Trenberth's detailing of the causes of this damage, suggesting that his reasoning was not allowed. He had a provocative section titled, as you see here, Unsupported Logical Leap of Trenberth's Analysis. That's part of his testimony. It's followed by the claim that Trenberth had failed to make his case for the plaintiff. Specifically, the analytic support that Trenberth had given varies, but his conclusions of the injuries to plaintiffs suffer from the same failure to connect his conditional approach conclusions to plaintiffs' local circumstances. So it turns out that this unsupported logical leap actually consists in taking an instance from a generalization. Trenberth is taking a general statement, generalizing over many individual cases or members of a group about a phenomenon applying to an area of the world or members of a group or pattern of physical world, picking out one of those cases as an example, which Weyant then describes as an illegitimate leap of logic. Here's what it's like. Consider a basket that we know is completely full of red apples. That's been established. Take one apple out of the basket without looking at it and say, we have a red apple. That's not fancy logic. But Weyant notes that, and here's his complaint, Dr. Trenberth states plaintiff Nathan has experienced thawing permafrost, wildfires around his home. Thawing permafrost is uneven, more likely on sunlit slopes, has led to tilted and broken buildings and frost heaves. Then there's wildfire. These harms are made worse by human-induced climate change. That's Trenberth. Then what Weyant says about this in response is, as with other examples, Trenberth does not address any confounding factors that may have contributed to the specific weather outcomes in Alaska 2015, the analysis of which is essential to reach a scientifically valid conclusion about any causal role played by human-induced climate change on plaintiff Nathan. Okay, so no causal claims could be made about anything because of confounding factors, according to Weyant. So we're going to take a whirlwind tour through some of the requirements for the kind of scientific causes that may be appealed to in tort law for establishing responsibility. This is actually a complete list, which is expanded in our paper. We start with the first, the plausible causal claim, which we've already shown you here. You need a plausible causal chain established by climate science. Second, you also need the articulation of possible alternative explanations for the bad outcome. In addition, you need to have tests that could discriminate between those various explanations. Then you need to show the collection of all relevant evidence, no matter what it supports. And then you need to show that the bad outcome is actually more probable with the factor you claim, global warming, and not something else. And basically that's the story, which of course the IPCC has already done. So at this point, it's important to note that the IPCC report is, as a condition of the lawsuit, granted as providing basic facts agreed to and accepted by both sides. So as such, the defendants can't go against the IPCC. So let's look at some results from the contemporaneous IPCC reports that Weyant actually cites. Okay. The IPCC report increased wildfire frequency with medium confidence, with a major contribution from climate change. with regard to the IPCC on permafrost, we find the IPCC has high confidence that climate change made a major contribution to widespread permafrost degradation. More importantly, this shows that Weyant's scientific reasoning about human-caused climate change is incorrect. We know from the IPCC report that the science is solid on the cause of human-made climate change on permafrost damage. Conditional analyses of permafrost damage do consider the confounding causes to specific weather outcomes essential to establishing the veracity and validity of basic, primary, efficacious, sufficient causal factor in that weather outcome, which is what human-induced climate change acts as, with high confidence as a major contribution. So let's make this into a storyline research question. Given that the permafrost damage occurred, ask how much worse did climate change make that damage or impact? And we know the answer to that from the IPCC. We have high confidence of a major contribution by climate change. So it's scientifically incorrect to say we can't reach a scientifically valid conclusion about any causal role played by human-induced climate change on this plaintiff. He's moved the goalposts for attribution inappropriately to require a complete detailed local account in order for the plaintiffs to have what he calls, quote, sufficient evidence, end quote, for their case. This moving of the goalposts action is, in fact, a classic move of big tobacco, creationists and anti-science folks from all over, including contemporary anti-vaxxers. But no such perfect standard need be met. The standard that need be met has been met by the testimony of the climate scientists to establish the increased severity of the damage to the plaintiffs by extreme events in their neighborhoods and areas due to human-made global climate change, which can be shown using both storyline and probabilistic approaches, which in their methods take account of contributing factors. So Weyant is mistaken on the science of attribution and on the logic of this case. Some of the work I've just reviewed is published in the second paper on this slide with Ted Shepard, which came out last summer. And Berger et al. Note that much can be learned from the preparation done regarding Juliana, as it is a model for future applications of DNA science. In each instance, the court will decide the case following this civil legal standard of, quote, more likely than not, end quote. So can researchers support a link between global climate change and, for example, fires or floods that may have caused damage or harm, as Trenberth did for the Juliana case? And what standard of proof should be applied in court for the scientific work on extreme event attribution? One relevant standard of scientific evidence comes from precedents in tort law, which would be applied in the climate case, according to Berger et al. However, it turns out Weyant has company as a skeptic of Trenberth's analysis and storyline approach. In the write-up in Science magazine of the Juliana versus US trial, science journalist Julia Rosen, who I also spoke to about this issue, starts by confirming that these confounding factors referred to by Weyant are true but irrelevant to whether warming contributed to a particular weather extreme. And she got that from Drew Schindel of Duke. Okay, so far so good. But Rosen continues. But Trenberth's approach is controversial, notes climate scientist Freddie Otto of the University of Oxford. Now, who you may know as a founder and a co-creator of the probabilistic approach, who says researchers, Rosen says she said, researchers can now at least partly attribute extreme events to warming, Otto says, but Trenberth's method isn't able to rule out whether a particular event would have occurred even without climate change. Okay, But need I point out that this last capacity of the method that Otto discusses is not the attribution question at stake from a legal standpoint or a storyline perspective. On a storyline approach, we determine the various causes for climate extreme events, thus making it more crucial for appearances in a civil courtroom and places where causes of events matter, because we are looking for responsibility for damage or responsibility for future changes. And this last quote from Otto is a counterfactual about an extreme event's occurrence or non-occurrence, and that's the sort of thing risk-based research questions ask and analyze. That is counterfactuals about classes of extreme events, and not about the causes of individual events, which is what we discover using the storyline approach. In other words, Trenberth can answer his own and the legal questions, but he can't answer this risk-based question. What the scientists are trying to do in the context of the plaintiffs is tell whether a singular extreme event at stake is partially attributable to warming. And the Otto quote, can attribute. Quote, researchers can now at least partly attribute extreme events to warming, Otto says. And so she admits that they can be. And that's what it really comes down to. But the Juliana case actually demonstrates the strengths that the storyline has for highlighting legally appropriate causation that highlights the roles of social values and informative values-based analysis. And as the storyline approach becomes more widely accepted and understood, dissents like Wayne's will become rarer and will look more and more illogical and unacceptable. In fact, the storyline approach has become widely accepted since Naomi and I published our paper on the debate just 4 years ago. And what was once a fierce debate lingers on only in some corners of the DNA community. In sum, then, I've presented today various angles on the roles of social values in climate science in action and shown that they are there, whether we recognize or acknowledge them or not. And sometimes they come to the fore and motivate disagreements about methods. We could see this in disagreements about storyline and risk-based methods and their different roles in scientific explanation and societal issues. Because risk-based approaches can give probabilities of risk, but not causal accounts or well-justified or grounded future projections, they're useful for some applications and calculations, but not others. Nor can they play causal roles in loss and damage claims that involve tort law or its international equivalents, as nearly all of them do and will do. They do not present the right kind of causal analysis to satisfy US tort law requirements and its equivalents internationally. In a complementary manner, storyline approaches can give informative causal individual accounts of extreme events, but not quantitative accounts of them that may be desired at various government levels, although they can give well-justified predictions using their causal analyses, unlike the risk-based accounts. Finally, they are precisely the kind of causal account necessary for legal contexts involving loss and damage claims that are almost always evaluated in the context of tort law or its international equivalents. So we explored the roles of false negative and false positive error in evaluating which methods might be appropriate for a given social context and set of social values, with perhaps surprising results. It's often claimed that the risk-based approach is clear of social values, that is, it doesn't get it down in the mud like storylines with social values, preferences, or anything messy like that, and only gives us clean probabilities that we can then use or apply. But that picture is false. Values, including social values, are deeply embedded in the analysis producing those risk-based probabilities, as we discussed. If you have only one take-home from this hour, please take this single fact. The risk-based view, in its choice to avoid false positive results, that is, to avoid making a scientific error to say that climate change affected an event more than it really did, is daring to choose to endanger people and societies. The storyline approach, in contrast, chooses to make the reverse error and avoids making false negatives over providing more information to them, as the storyline choice of risking too many false positives does. And that's what I have to say today.
Okay, thank you very much, Lisa. Leandro, why don't you turn on your camera and ask your, or make your comment or ask your question.
Hi. We are used to have to demonstrate the human influence of the climate for each particular event. But we know that we have a lot of evidence of the human influence on the changing claim. So do you think that could make sense to change the presumption of innocence, so it has to be proven if that event would be not affected at all by climate change?
Do you mean in the legal context or just in general social analysis?
But in both.
I see. Well, I think the legal context it needs to be treated separately. It has been argued, especially by Kevin Trenberth, that altogether we need to think of all of the climate and weather now on Earth, given climate change, differently given warming, and that all weather events take place now against a different background than they used to. Trenberth is inclined to say that, yes, as a storyline, as one of the originators of the storyline view, yes. He has quite radical views on this.
Do we have any other questions? Lisa, I posted in the chat a link to your science and anti-science paper from 1996, because I think there's an interesting parallel there.
Do you?
Do you agree? I mean, it just seems to me that was a case that we maybe don't have time to go into this too much, but there was what was called the science wars, when there was social and historical critiques of the way science was done, and a number of philosophers of science, well, scientists too for that matter, but philosophers of science argued that there was no role for any of these values in science. And it's a beautiful paper. Lisa lines everybody up and slices them to pieces, I would say, and shows all the inconsistencies. And because essentially it was the same thing. The claim was that the so-called rational approach was free of values, but their appeal was to values, because they said we have to defend the integrity of the scientific enterprise, which is not too different from the argument that was made here. So I don't know if you also agree with that, Lisa, but
I think that you have a better and sort of higher perspective, 10,000-foot perspective on my work that I don't have, and the perspective that you just gave actually makes a lot of sense to me, but I couldn't have thought it up myself. So thank you.
Oh, okay.
Thank you. What you said isn't wrong. No.
It's behind a paywall, but if you can't get to it, let me know. Yeah. Okay. Well, we're over a time. We shouldn't. I shouldn't indulge things, but I was also interested by your link between model confirmation and storylines, because it's not a parallel that's immediately obvious, it seems to me, but I think the causal account is kind of the common theme, isn't it?
Yes. Because
when you take a model, as you say, a model of confirmation is kind of a foreign concept to kind of classical, experimental science point of view. Yes. And the storyline approaches too. It's more of a narrative approach. So it's kind of an interesting, parallel there. So thanks for raising that. Okay. Lisa won't be with us for the rest of the week, at least unless she surprises us. She doesn't have a second act. She gave both acts today, but I put her email in the chat, and I'm sure she'd be happy to answer any questions or receive comments from any of you. So thanks very much, Lisa.
Well, thank you, Ted, for the opportunity, and it's lovely to be able to chat with all of you. And please do send me some questions, comments, or if you'd like specific papers, just let me know.
Yeah. All right. And for everyone else, yeah, we have a practical session tomorrow morning, 10 o'clock UK time. All right. Bye.
Bye. Thank you.
You should stay and see all the see the comments here. We have some.
Oh, I can't. Oh, how do I get to that?
Chat.
I'm not seeing chat on my. Oh, here we go. Here we go. Oh, look at that.
I'm going to stop the recording now.
Yeah.
Thank you.
Yeah. Thanks, Jen. And